Dear students, hope you are well and staying safe at home. Today I'm going to move on lesson 2, and we will start with page 21 and we will finish on page 24. So, the nature of matter. This chapter is focusing on matter. What is matter? Anything that has mass, weight, you can touch, okay, and it takes space, it takes a volume, it has a volume actually. So uh, matters can be divided to three main states: solid, liquid, gas. Solid like salt, sugar, that is a solid form, and liquid is like a water, like ethanol or alcohol, any other liquid form. So the third one is gas. Gas like a spray that you use a spray, okay, like perfume. When you spray a perfume, the perfume change from the liquid to gas form, okay, it's a form of the gas. It produces actually gas, and like carbon dioxide or the uh, like nitrogen gas. So these states can be changed to each other. Like solid can be changed to liquid if we change pressure and temperature. Okay, if we change pressure and temperature, we can change solid to liquid, liquid to gas, gas to solid, liquid to solid. So for moving from solid to liquid, liquid to gas, we need to increase the temperature and increase the pressure also. No, decrease the pressure and increase the temperature. When we are going to change gas to liquid, we need to, or liquid to solid, we need to increase pressure. Okay, we need to put pressure and reduce temperature. That means, for example, a gas to liquid, we need to decrease the temperature. That means the matter become cold, and uh, reduce and increase the pressure. I will explain you more in next slide. So please look at table 2.1 for general properties of the three states: solids, liquids, gas. So yeah, this is more details about the pressure and temperature, as I explained some. um, how states can be changed to another state. We have three states: gas, liquid, and solid. I said by changing pressure and temperature. We can do it in fixed pressure. Okay, we want to see what happens if pressure is fixed or constant. If we make constant the pressure, and but the temperature has changed, has the various points. So molecule with higher temperature, they move more, because the particles or molecules or atoms, they get energy from the fire, from the temperature, or from the heat actually. So the energy would increase, and if the energy increase, they move a lot and then they hit to each other. Okay, so the volume would be increased also. So finally we will have expansion. Okay, that means the volume expand, the matter would be expand, and energy is higher. But if we don't give any heat or any temperature, so the energy is lower than the other one, and volume also lower than the other one, and we would get a, contraction matter. And our matter is contraction, so it's not expansion. So because energy is lower and volume, the particles are not moving fast like here, so the volume is still constant or lower than the other one. So this is the situation which pressure is fixed. We are not changing pressure, we are not dealing with pressure. But if we fix the temperature, okay, here we don't give any heat, we don't give any um, actually energy, but we are just going to change uh, change the pressure. If you look at the left, okay, the left one, the left picture, so the volume is high, and the particles or atoms, molecules, no different, they are moving slowly around, okay, they are moving slowly around the environment. But on the other side, on the right, you can see that we are giving more pressure. If we give more pressure, so the particles would be closer to each other, and then they hit the surface of the surface of the container, they hit to each other also. So it would be different, okay, the energy would be higher, not as much as the temperature, but still because they are moving faster, okay, they can move faster because they are compressed. So the volume would be smaller in the case if we give more pressure, okay, the volume would be smaller compared to the other one on the left, which there is no pressure. So this is the way of fixed temperature. But changing between the states can produce totally six um, process, okay. Here you can see the changes between physical states. Physical state is a gas, liquid, solid. Why we say physical states, we don't say chemical state? Because it's a physical, that means the nature of the atoms or the nature of the chemical has not changed. If you consider water in the gas formation, water, the chemical, I mean, the chemical property of the water is H2O, okay. So it's saying when it in the liquid form, or it's saying when it get cold, like ice formation or the gas formation, it doesn't it's not different actually, the chemical property is same. That's why we say physical states, okay, it's a changing between physical states, not chemical states. So if we change the chemical state, the how to say that, it's a chemistry of the compound would change totally. Like water totally changed to ethanol. Ethanol changed to like caloric acid. Okay, totally the chemical would change. So changing between gas to liquid called condensation, and from liquid to gas is called evaporation. The evaporation, like when a sun heat on the surface of the lake or sea, so then water has evaporate and move up to the sky. Okay, that is called evaporation. And condensation, like any rain is changing from the gas in cloud to the liquid form. Condensation is like a rain. So sublimation, sublimation, only a few chemicals are able to make a sublimation. Like I will explain you next slide, like carbon dioxide or like iodine. Some chemicals, they can change from solid to gas directly. And but changing from gas to solid, called deposition, like a snow. Okay, like a snow, which change from the gas directly to solid form if the pressure is high and the temperature is very very cold. So changing from solid to liquid is freezing. Actually, sorry, from liquid to solid is freezing. The example, like when you put a water in the freezer of your house or fridge, so the water, after a while, the water would change to the ice. So that process, the chemical change is freezing. And melting also, if you hold the ice outside, so the ice would melt, then the process or physical changes is melting, called melting. Melting and freezing, there is a compression that we are going to compare between melting and freezing, and I need to explain sublimation also, and compression between evaporation, boiling, and condensation. So first, melting and freezing, the temperature which change solid to liquid is called melting point. Okay, so if we are dealing with temperature, which temperature? Okay, each chemical has different melting point. Like water can change from the solid when it's formation of ice to the liquid, which the water liquid. So it happened in 0 Celsius, so called melting point of water is 0 Celsius. But this is not same for all chemicals or liquids. Okay, like this is different for methanol, ethanol, or hydrochloric acid, or sulfuric acids, or many other chemicals. So melting point is different, and melting point is related to the temperature, which temperature that solid can change to the liquid. um, Subsequently, freezing point also. Freezing point is related to the temperature. The temperature which liquid change to the solid is a reverse. Okay, it's the opposite of melting point. Freezing point is opposite of the melting point. Both of these two are same for water. Okay, maybe it's different for other chemicals, but for the water it's same. The meaning is same. That means melting point and freezing point both are happening at 0 Celsius of the temperature. So sublimation, as I said, only a few number of solid can change directly from the solid to gas, like carbon dioxide. Carbon dioxide can be changed to the solid formation. It's called carbon dioxide ice, if I'm not mistaken. Yeah, it's called carbon dioxide ice. It can be produced by high pressure and very low temperature. So carbon dioxide actually, the stable formation, the stable form of carbon dioxide is the gas gas formation, but it can be kept in the form of solid. if we keep it in very low temperature. Also iodine sorry iodine is a formation of gas, but can be changed to the solid form. But after we get the solid form, they need to be only faced with a little bit like a room temperature. Then they can be changed to the gas form easily, because they are not stable in the formation of solid. They are stable more in gas. That's why when we make it in the solid form, and then if we leave it in the room temperature, they would change to the gas form easily. So this slide shows that it's some explanation for evaporation, boiling, and condensation. Evaporation is the change of liquid to gas, and if we have more surface area of the liquid, so we can get more evaporation. Here you can see the two examples with for two different container, two different chemistry labs dish. So those are different. Okay, on the left you can see there is more evaporation. Also you can compare a lake or a small pond, okay, with a sea. The sea provides more surface area for evaporation, so it has more evaporation. And yeah, this is different between evaporation and boiling. uh, you know there is evaporation, but if there is more heat, if you give more higher temperature or heat or energy to the liquid, so some bubbles of the gas appear in the liquids. So in that moment, okay, in that moment, uh, we can we have a boiling. That moment, um, what we call the liquid is actually boiling. Okay, so um, the temperature which bubbles of gas appears inside the liquid is called boiling point. Okay, that temperature is boiling point. So comparison between water and ethanol, we can see that water can be boiled in 100 Celsius, but ethanol uh, would um, would be boiled at 78 Celsius. That means ethanol is more volatile. Okay, that means ethanol molecule run away from the surface faster and easier than the water. So there is some more reason for this, but that is out of your book. Water molecule can attach to each other stronger than ethanol. So ethanol um, can run away from the surface, and they are easy to move up, okay, and change to the gas formation. So that is called that can it can be said that ethanol is more volatile. Okay, so boiling point is affected by surrounding pressure. It depends on the pressure. Okay, if there is if you have more pressure, the boiling point would be higher. If, for example, the water, if we are going to boil the water in mountain, okay, there is lower pressure in mountains surrounding our atmosphere. Pressure is very low in mountain, and so it would be higher. The boiling point would be higher. Sorry, would be lower. Like pressure in mountain is lower, so boiling point in the mountain, if we are going to give a heat to the water, the water would boil maybe around 90 or 85, something like that. So the boiling point would decrease in lower pressure. In higher pressure, if we are in atmosphere, in a place uh, which surrounding pressure is higher, so boiling point would increase. Like if you are going to give a heat to the water in order to boil the water, in that pressure, if the pressure is high, so water would be boiled in like 120, 110. So it would be higher than 100. If you hear that a standard pressure, that means uh, it's a normal point, it's a 1 bar. Okay. If a standard pressure means you are measuring the thing or chemical or doing the experiment in 1 bar. 1 bar is a standard pressure. So mostly scientists trying to do their experiment in the standard pressure, and they will report their experiment in standard pressure. When they say a standard pressure means they did their experiment in 1 bar. That's all for today. Thank you so much. Please leave a comment done as your attendance. Thank you so much. Take care.